Okay, in this video I'm going to show you how to add two voltages together. Sometimes you have a sensor, a low-level sensor, and then you have a DC amp, and in some cases you might have a special amp that needs around minus 10, somewhere in that range, minus 10 volts, and it won't work with just the sensor voltage. So you have to add something into that, and that's what we're doing. So my particular amplifier, I had an amp that needs negative 9.5 to negative 10.5 because I've got a 1 volt swing here, plus or minus 5 and 0.5. So I'm adding that into the 10 or subtracting it from the 10. And that's what I'm trying to do here. And I'm also, the key point about the circuit, I don't want to load the sensor down. This may come from some sensor and maybe its output impedance isn't super duper low. And that's why I have the 100K here. Is I don't need the 100K, but it's to prove that even though I'm going through the 100K, I'm not loading this down because it's just a simulation. This isn't the actual sensor. Okay, this cap here is coming from ground, so it's a ground feed. And then this one is coming from our oscillator. This is the square wave for the oscillators up here. Okay, this is, I don't know the exact frequency because this software won't go much above audio, like 20K or something. So this is above 20K. It could be, the frequency is not important. The higher the better, probably. So frequencies are just coming through these 200 picofarad caps. They're getting rectified. And the reason for the ground cap is so this, the voltage developed across here, the output cap, is not tied to ground. Okay, so it's floating above ground because of this cap. And the 10 meg is a bleed off resistor, so it helps discharge this cap. Okay, so what we're doing, essentially, we've got, you can see this voltmeter here is measuring the voltage across the cap. We've got 11.5 volts. Okay, and this voltage here is referenced to the grounds here. Okay, we're mainly interested in, this voltage for the following circuit, because the following circuit we want to have it referenced to ground. So it's this voltage all the way up to here, and what we got there is 12.0 something. So what we're going to do is mess with the switch and see how much it swings there. So 12.0, and now it went down 11.0. So yeah, we're getting the full 1 volt swing there. You can see 11.0 roughly, 12.0. Everything's working perfect. So, and this voltage here is not supposed to change because it's just being added, right? So all we're doing is adding this voltage here, which is floating above ground, and adding with this. Okay. So there you see it. Okay, and this, okay, if I put my mouse on this line here, it turns blue. That indicates the scope output, which says DC output over here, also changes to blue when I do it. So you'll see when I toggle this, that you'll see the effect in that little scope there. Okay, so yeah, that's kind of cool. Okay, so everything's working. So it's a very simple circuit. The output, hasn't got a lot of power to drive something. It's made to go to something like an op amp or a transistor amplifier. So it doesn't need to be that powerful or anything. But that's how it's done. So I hope this video has been informative and helpful. And this is just your regular 555 timer. Okay, got all the values on here. Okay, again, nothing's really super critical. All you need is a square wave coming in here. I'd recommend going above audio and then just feeding it through this circuit. So this is the magic circuit here. It helps combine the DTs. It's great. It's creating the DC, and actually, I know my voltages that I mentioned before. I wanted negative 9.5 to 10.5. I didn't really play with the calibration. I guess all I could do is just lower this voltage, and this will come down. Okay, but the main thing I was looking at here is just to get the 1 volt difference in the swing. Okay, thank you for watching.